All right, let's get it. Part 2. Self-test, baby. Well, actually, not yet. Gotta learn more. Gotta finish this. Okay. I was in Unreal a second ago. All right. I had to fix this fireball's location so that it summons. And then if the player's looking at a target, not the air, then it goes to that target exactly. But if you're looking in the air, then it just goes to where the player's looking because there's no actual location to go to. Okay. Need to figure out a better way to make it hit things too. All right. So we have the empty. Now we need to actually get an integer, and we're gonna do get rand int, and this makes it feel like it's a yeah, sure. And this returns a standard uniform int distribution initialized to whatever the range you want. And it's going to call empty. Okay, and the point is that this guy gets initialized at runtime by seedMT. That way we can create one instance. Well, we can create this if we want. I mean, I guess we could, right? We could do it, but then if we did, then what would be the point? Well, it's like a namespace. The point here is that this guy, oh, so far all these are private, so we can't even do random getter. Doesn't even give us anything. So what we need is the one public thing to be the get random int. And now we can do random getter get rand int. And what we could do here is and we're going to say between 1 and 100. And actually let's do a few. Okay, 4 and x is nothing. 2, x is less than, let's just say 10 of them. X. Could do this and say num1, this, num2. All right, should look good. Sure, and we could do a thing to make it look the same, but we're already including 100 here, so we could get from 1 to 3 decimals. I mean, sure, I guess we could do a thing to add the zeros to make it nice, but it's fine. Cool. Okay, what else do we want? We don't want the Mersenne Twister to be const expression, because we could remove inline if we did that. I mean, we could do this. The problem, though, is that he's being seeded. Well, the problem, though, is each time he's called, the values inside change. Yeah. Oh, makes sense, true. And it's not eligible to be const expression anyways. And what about this? Oh, we could technically... No, we can't. Okay, never mind. Oh yeah, I guess because it's calling a random or uniform in distribution, and that isn't known at compile time. So there's no case where it could evaluate at compile time, I think. I mean, we can make this a constraint device. Well, actually, we can't because what happens if we did? Uh-oh. It can't take non-cost values, seems like. Alright, what else here? Oops. Yep, I did the same shit. Generate, sure. Yep. Same shit. I don't like, well, I mean, I guess I don't just, well, I guess, yeah, my way of putting this here was actually weird. We have a function here, and then the value it returns, I mean, if we wanted it to be organized. I mean, we could say, oh shit, wait, hold. It doesn't see empty here, huh? Thought this is one of the things where it could be initialized like that, huh? What am I missing here? Oh, never mind. Okay, never mind, I was right. The point is that we can have the properties, I think the functions can use them wherever. So we could say, the functions can use the data members without the data members being before the functions, but the data members cannot use the functions before the functions. Gotcha. Which is why we generate, we create a seed sequence. Hey, and it's made the exact same way, cool. Yep, same shit, and those are private, so we can't fuck with them, cool. Specifically because it's static. Well, yeah, because it's static, I don't like that static is omitted right there. The important part here is the static. Hence, static inline part. And inline lets us put it inside. So not only does inline make it so that, well, hold on. Inline lets us put it inside the definition instead of putting it outside, and we can also include it in header files because the linker knows to deduplicate it when it sees multiple definitions. It's static so that we can call it and use it without having to do dot empty because it's not part of an object. The member function is static, exactly same thing there. All right, cool, makes sense to me. Friend functions. We were learning about this earlier in a little paper that was talking about when or what types of functions you should have in member and non-member functions. Here it is. Oh, speaking of non-member functions, it's the first word I read. Okay. They were saying you could use friend in other cases. So it's like use it as a non-member if possible, and then a friend, and then a member, I think was the hierarchy. The problem here is it's probably going to talk about complexity and like cluttering a whole class, making it less readable, and figuring out a real ideal way of organizing functions. I mean, so far I don't see any issues about like why. Well, I guess the point would be if you had a friend function, a function that doesn't need to be like if you had a class and you wanted a function that was called print, but you didn't necessarily want it inside the function because you wanted the share print maybe as an overload, but you wanted print to be somehow related to the class, then you could make it friend. I'm not sure. Seems like you would just leave it as is and then print the function as an overload without being a friend. I'm not sure. This is a fucking bop and a half. Thank God I speak English, right? Fuck. I made it worse. Whatever. Yep. You have a storage class that's focused on managing a set of data, and you want to display the data. The code handling the display is complex. And it has a bunch of checks and does this in this case and this and that. You could put the storage management functions. So you have the storage management in the class, but then the actual display of it, meaning that it's one thing you do with the data, but it isn't paramount to the class, maybe? It isn't involved with the actual storage of information in the class. Like maybe you have attack functions inside this enemy class or character class, but you don't have everything that could happen to the class in the class. You could also give them separate. A storage class and another class. Why would you want another class? Yeah, that separation of responsibility is retarded. But the display class, exactly, it wouldn't be able to do it. So now you'd have to use the freaking public the public interface. Fuck all that. I mean, it'd be able to do its job, it'd just be a pain. Unless there's something you can't make public for some reason, but I don't think so. Alternatively, prefer to use a non-member over a member. Yeah, overloading operators makes sense. Oh, Oh, it's a non-member, but it has access to the class's data members. Oh, shit. Wonder how you designate what it's a friend with. Oh. So we use a non-member, but maybe it's a pain in the ass to get the information from the class to the function. So we want to get it easily. Meaning making the operator overloading maybe even a friend. So then you can just you can access the private. Oh. It's like it brings it in. So it's no longer the part of the public, it's part of private. So now it can access the private shit. If access functions already exist and it's efficient, they're cool. But what if those functions don't exist? Well, I mean, why can't you fucking make them? I mean, we could add member. We'll hold. So we could add getters for something, but maybe we don't want to allow everyone. We only want to allow some things. For example, we have, let's see, a print function that we want to get this. The data members straight away. Like, so let's say we have private data members, but we need that information somewhere, but we don't want people to even be able to get it. Or other places to be able to get it. You only want a specific place to be able to get it. So your reset function, non-member function, isn't able to get the data members, but your print function can, because your print is a friend. Subvert access control on a case by case. Friendship is magic. In the body of a class, a friend declaration. So do we say the friend? We say friend and then the class name, and then later we can define the class and put friend in front of it. Maybe, or we don't, or we just put friend to show because it's the class that determines who has access. Wow, the difference between 50 and 100 is not huge, but once we get down here. So, shoo. How about this then? I have until 15. Sure. Class gun private bool is firing pin disabled. And so if we have a gun, I create a gun, AK-47, okay, hold. True. Firing pin's enabled, it can shoot. But We can't get anything. Nothing is public for us to get. Only the constructor. Oh, makes sense. Because if you make the constructor private, then you can't even make it. Okay, good. Oh, you could make it private, and then that makes it so only a friend function can create it. Oh shit. But then we have another function called friend hold void replace firing pin. Okay. Void replace firing pin. Okay. Fuck. Why isn't it working? Nah. Hold on. Friend. Nah. No, don't put friend out here. Makes sense that you don't. It says it right there. Needs to be in the class. Alright, now how do I get that access, yo? Oh! Oh wait. Oh wait, hold on. Can't get it here, but I can get it here. This means that we need to pass it a reference. Gotcha, because we're talking a private data member, not a static one, so we need a specific object here. And we'll do a const gun reference gun dot fuck. Oh wait, fuck. Nope. How do we access it? Oh fuck, hold on. Here we go. I was a retard. Because now the signatures don't match. Boom. Boom! I was a retard. I figured that's the answer to everything. If hey. Oh, oops, hold on. Sorry. If not, hold. Fuck, we're treating it as const. Yo. Oh, now it's truncate, or now it's converting from const to non-const. Can't do that. And if we wanted, we could have another function that is able to actually get it. So now we could do friend bool get firing pin. And then we could have bool get firing pin const gun reference gun return gun dot m firing pin enabled. And now we could do standard character output, standard bool alpha, get firing pin AK-47 false. Excuse me. And then we could do replace firing pin. Excuse me, AK-47, and then get firing pin AK-47. think. Yeah. Oh, so it actually, okay, that's fine. All right. Cool. And then we'll do so it's false at first, the firing pin doesn't work, and then we replace the firing pin, and then true, or engage firing pin, whatever the hell the proper syntax is. So we can now send this guy through a reference somewhere else. Friend functions, because they're non-member functions, they do not have a this pointer, so we can't just, well, duh, because it's not a member. It's a function that's defined elsewhere, and could even be overloaded with some other shit, so it has nothing to do with the function or with the data member, with the class. It's just that we make it a friend in the class. So now what about how about a class where we use operator overloading to print it, but we can't get the members otherwise, and it's a friend function. Friend, okay, this could be interesting. Class score, and what actually, let's say class battleship, and then we have private int m ships sunk, m my ships sunk, or my ship locations, my ship location. Okay, we could say, yeah, I like mine makes sense here. And then public, sure, and then we'll say battleship, and we create it with an int x, int ship location. Okay. And then we have, okay, we created a battleship called Ethan, and this is just the game, so this is my side of the game. And we'll say I have one located here. And actually, we could say ship location X, X, and ship location Y. I have one located at 5.7. And now I want to print it, so we're going to say friend, standard, ostream reference, operator insertion, standard ostream reference, and it takes a const battleship reference. Battleship, and it has an output device. Uh-oh, hold, you're about to find out, chill the fuck out. And then we say standard ostream reference returning guy called operator insertion, standard ostream reference output device, and then const battleship reference battleship. And what we do is we say output device, output battleship dot, boom, y, battleship dot my. And now we could do hold, and then return duh. And then I prefer to do this when possible. output Ethan dot, or hold on, wait. Output, oh, Ethan. Boom. And so now we're able to get the private data members via const reference using a friend function of a class. These guys are private and we can't access them otherwise. Because if we say Ethan dot, nothing. Battleship, nothing. Only the constructor so we can actually create it. Cool. 15 more minutes and then we have to do self-test. Okay. Full access to private and protected. Oh, you get that itch like right on your underwear line? Holy. In this way, a class can selectively give other classes or functions. Wait, what? Oh, I was misread that as the function giving other ones. Like the class makes this guy a friend, but this guy can make other friend. Oh, hell no. In this way, a class can selectively give other classes or functions. Oh, shit. Oh. Oh, interesting. So I could have a class card with private data members in a class hand, and the hand can't get the data member of the card. Oh, or really, it's yeah. Well, yeah. Oh shit. So I would need to make the class a friend in order to even get it, because even though it's inside the class, it's a different class. We can't get those private data members. Oh, fuck, that's true. Okay. Now I see the value of making friends here. Okay. Well, yeah, how's it gonna be accessed by the one desiring access? No. Yeah, because then it just makes you able to void any of the rules and traditions set by the grantor. So, oh, I could just amend the rules instantly because I say that I'm a friend. Bro. Nah, the thing doesn't say you're a friend. You ain't coming in, buddy. Makes sense? It's the class that determines it, okay? For example, if we make the display class a friend, the display can then access all the members. True. Display could use it to do, let's see. While still being structured separate. Makes sense, okay. Excuse me. New song. Not this one though. Got tired of that from yesterday. Could be good. Friendship is granted to non-member functions. Non-member functions? Friendship is granted to member functions? Interesting. But member functions can already... Interesting. And other classes. Non-member, friend non-members. And then friend classes and friend member functions next. A friend member function? Do we mean a class is inside a class and we're making this class a friend of the nested classes? If that's true, then I think it would say nested friend. Well, it doesn't have to be nested though, that's the point. It could be nested. I guarantee if I click this and we do Control F, we're gonna see nested. I lied. Fuck. Fuck. Never mind. A friend non-member function. Access to private and protected. All. Just say fucking all. All. Well, the point is that it can access private and protected, so shut up, Ethan. So it was a member of the class, but otherwise it's normal. Just like when we overloaded the insertion operator, makes sense. Okay, in main, we're creating an object. Value initialized. We're calling a function to add stuff to it. And that means it's probably accessing the actual value and it's adding it. And then, or maybe not. No, it's not, because that's in the accumulator. That's a member function. Duh, retard. And then we're printing it. And print. So far, exactly what I was expecting. Has a private M value. It has a public constructor. Wait, what? Oh no, it's not the default constructor. And then we have an add function, and all it does is add the value you pass to it to its M value, and it can access it because it's a member function. And then we have the friend one, so that print is a friend. Okay, it's exactly what I was expecting. I'll wipe my monitor off tomorrow. Well, specifically, it's taking a const reference of it, but it's fine. Yes. Yeah, makes sense. Yeah, it's not a member, so it doesn't have a this pointer. Defining a friend non-member inside a class? What are you talking about? What? If it's a friend, then it's defined inside as a non-member, so we don't do dot to get it. How do we get it? Oh, we can just call it straight up. Wow. This is kind of busting. Why? Doesn't this still clutter it just like before? You may as well have made it a member, right? Maybe not? Because it's a friend, it's treated as a non-member. Syntactically preferring a friend non-member. Why would we do this? Oh, hold. Well, my curious is why would we prefer it in a class? But okay, in this case, we're doing it outside the class. Yep. Oh shit, finally. Wait. Ah, gotcha. The point here is that it makes it make more sense. So if we had a class, like let's say we had a player and it was a guy. Let's say we had a class called bodybuilder and he had a function called flex off, and it was a comparison of him and another guy's muscles, like in Full Metal Alchemist, right? So you could have it be a member function where it gets a this pointer to himself, and then it takes one other object, one other bodybuilder, const reference, and then you compare the implicit object's member to the members, like his, I don't know, whatever the hell, vascularity and all this shit, and size and width and whatever the hell, the width of the back and the taper, all those kind of things, and you compare it to the other. The problem is when you call that, you're calling it on an object, and you're only passing it one object. So it's like flex off. So it'd be like Fred.flexoff, and then in parentheses, Callie. Why not flex off Fred and Callie? That makes more sense. The point here is that it's a function that we don't want to call as a member function. So it seems like another value of friend functions is not that it reduces the clutter, it's that the calling is a pain in the ass. And you don't want to have two different ways of calling it. You don't want to be able to call it dot something, but then you also could pass it, then you'd need like an overload, like, I mean, you could, yeah, no, that would be shitty. Because if it's a member, then you would have to call it on an object. But if it's a non-member, you don't have to. If it's static, you also don't. But if it's static, it doesn't have access to the hold. But if it's static, it doesn't have access to the members. It only has access to the static members. So the friend helps the syntax where you can call the member function and actually have to pass in two objects instead of, or pass in one object instead of passing in none or passing in one. I mean, I could make that example, but I already articulated it well enough, I think. And this is exactly one of those cases. So we say, okay, cool, we create a value, and a value is a class. We have v1, we have v2. Okay, so we could do two different ways. We could say in value we have a member function, one explicit, an explicit value, so that, oh fuck, there are probably other cases where there were other cases where we had a constructor that only had one parameter, but I didn't make it explicit, so it could have been implicitly converted from the argument to that, which could have fucked things up. But I mean, I think it's kind of rare, honestly. I don't find too many issues with that. But it's more useful for other people. So when they use it, they get the expected value and they realize what you're allowed to pass. So, and it's just to be careful. So, we could have the member version and we do is equal to, but then we could also have the friend non-member is equal to. And the difference is that we pass in two objects versus one. And in one, we don't call it on any object, we just call it with two arguments, versus the other, we call it on an object and with one argument. And in this case, we're defining them, we're defining them both outside, just to do it, because we can define a member function on the outside as the implementation. And we can also do the same thing with a friend, because in this case, it's defined outside, as we would probably want. And what makes more sense? Are we saying v1 dot is equal to and passing it another, or just say is equal to v1 v2? This makes way more sense. All right, let me turn the fan back on because it's getting kind of cool. Fuck, I wish there was more time in a day so I could work more on Unreal. This is good. All of this helps me learn new stuff. I mean, this is fantastic. I'm glad I started doing this. Two similar functions that check if two things are equal. One's member, one's not member. Cool. One, we pass one implicitly and the other explicitly. Yes, because of the this pointer. Excuse me, the hidden implicit this pointer. Yeah, we have to mentally remember that, hey. Oh yeah, and inside it, we're not comparing v1, v2. We're saying m. Oh, it's because this is a member, and it's just weird. Well, I mean, I don't know about parallelism. We're talking about, I mean, we have an implicit passing, an implicit reference, or an implicit use, versus an explicit passing and an explicit use. But it makes more sense to do it this way because that's just how it's used. Yeah, there's no way. Because when we cover operator overloading, we're going to care where things come in the order. Okay. Multiple friends can be a friend of more than one class. Wait, hold on. Oh, a function can be a friend of more than one class at the same time, meaning we could have it. Oh, we could have a temperature and a humidity class and have a function called print weather. Make print weather a friend in both of those. Both of those constructors are explicit because they only have one parameter. All right, that's it for now. Oh, that freaking little like arpeggio. Bum, 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 bum. Ba-na-na-na-na-na. All right. $15.8. Look at this, bro. We came far. Getting there. Okay, it doesn't seem like that far, but I'm gonna be direct. Quiz me. Let's do all caps. Quiz me on all information covered in chapters and sections in these learncpv.com chapters and sections. No! I'm waiting. Music's gone. Fuck. Chill. Indian. That's not too bad. My typing has gotten fucking crazy over the past, really, since I started doing programming, honestly. It used to be like 120, even on there, which it's still a super easy test, but still. Ooh, more stuff. I like it. Let's go. We're about to, no! Ah, it's fine. I can order them like this. They all have a chapter in them, right? Nice. Okay, I can at least do like 1.1, blah, 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 blah. Man, this voice. Who is the singer? Is this Hanata? Who is this? Oh, shit. G5 Project, right? Fuck yes, bro. I knew this guitarist was crazy. Yeah, well, I listen to this for sure. 100% on Sky, right? Give me all the alerts. I don't care. Please, I will take them. Where'd the music go? What the hell? Okay. Please. Oh, great. Love it. I have to fucking aim like it's Apex Legends again. Oh, bro, can we chill? And this hitbox is terrible. Alright. Alright, let's fix this. Okay, well, fuck off with the linker. Alright. Declare a nested type inside a class. The point is that the type is to be defined where we're actually using it, so we have to define it early, and we can make it public or private. Public is probably best, because if it's a program defined type that's defined inside the class, then we probably want to be able to initialize it with the value. No, I'm picturing a class in an enum inside it, but it's defined in the private section. Sure, we can put a data member and initialize it now. Can't change it. I guess it depends on if we want it to be const or not. But if it's const, I mean, do we even need the enum? It's debatable. Okay. But that was the strat. It was like this. It was class, public, private, public, and the point, public, private, public, and the point was that we make it public so we can use it, but also before the private data member so that they can actually use the type, because the compiler needs to see, hey, this type exists, buddy, before you can define it. Just like a variable initialized with a function, the function needs to exist first, buddy. But the variable need not exist before the function, because the function has a prototype inside the function, but the definition is later. So the variable does exist before the function. Guaranteed. Ideally, with public access before the private data members, so the compiler sees the type definition before types for the types objects. That way, this lets us create a class and get the values, or get the create a class object initialized with the type value, since they're visible to the public. Example. Class gun. What do we want? Fuck, this isn't a good example. What's a good example of a class that needs? Oh, here it is. Cards. That could be one. Let's do Pokemon. Too easy. Glasses frame brand. Ah, that's gay. What do we do, bro? I don't like these. Whatever. Fine. Class computer public enum brand Asus. Razer's not a brand. Asus Dell. Alienware. Private brand. PC brand. Bop. And then whatever. And then public. Create a computer with a normal constructor that takes a damn brand, and it initializes PC brand. This is named wrong. This needs to be MPC brand, and this needs to just be MPC brand is brand. Bop. Okay. I don't like that spacing. It's shit. Excuse me. 1415.9. Excuse me. Declare the function anywhere inside the class with friend as a qualifier. As a qualifier. I don't even know what we call it. I guess we call it a qualifier. Yeah, because const is a qualifier. So with the friend qualifier. Then define it outside or inside class. Personally, defining outside makes more sense if we're trying to declutter the class definition. If we're just using it to get a non-member's syntax, helpful when we don't want the function to have this pointer. Doesn't get the implicit object, doesn't receive the implicit object. Then defining inside could make sense since if it's only used for the class. I could see that. Define a static member variable. Define a static member variable with the static qualifier. And define it inside the class if inline or const, and outside the class if. Why would we put it outside an inline? Is there a point of defining it outside if it's inline? Define it inside, and let's just say outside the class if not. Sure, I think that makes the most sense, honestly, right? How do you define a static member? Define it with the static qualifier. Like, what about, here we go, let's just do a little class. Class test, and then we have private static inline mx. Hey. Chill. What's wrong here? Explicit type is missing. It doesn't have a type. No. Fuck. Oh, wait, okay, good. Inline or const. Static const in my. Boom. Static in my. Uh-oh. it needs to be either. Well, could be inline too, buddy. Whoa! What is it doing? Oh, hold. Wait. It doesn't want static out here. Wait. Hold. What's happening here? Static int my. Oh, I'm fucking retard. Womp womp. Oh, it's actually okay. It's just undefined. Uh-oh. Oh, there it is. Must be const or non-volatile, const, integral, or be inline. Makes sense. Cool. Oops. Hold. Should have cut, not copied. The hidden this pointer, or what we could say, the hidden this pointer is a pointer that is a pointer that member function that non-friend, non-static because a class can have a member function, but it's not tied to an object, but it's still a member function. That non-friend, non-static member functions automatically get as a parameter. It was a parameter, and the compiler automatically replaces the compiler dereferences when the shorthand data members without specifying this data member. Static and friend functions. Well, static and yeah, I mean, and non-member functions too, duh. But yeah, static and friend functions do not receive a this pointer, so they require a reference, ideally const reference of the class object to use its data members. Wait, but don't static only get access to is it that static only don't get access to the private, or they don't get access to any class gun private mx needs a type int mx static const int my static get value const gun reference gun. Oh, here it is. Void. Well, I'm just testing it. Void get value const gun reference gun. What you talking about? Oh, oops, here it is. Bop. Gun dot. It gets both. Okay. I think I was right then. 14, 15.6. The explicit keyword prevents implicit conversions. So even though there's a constructor that creates a class from an initializer list, it can only, if the constructor is explicit, it will only take, the program will only compile if the class object is initialized with the class name explicitly placed before the initializer list to guarantee since implicit conversions are disallowed. A copy constructor is a constructor that takes a reference, ideally const reference, of an object of the same class, and uses a member list or member initializer list to initialize and new objects data members, i.e. instead of passing values to the it gets called when creating a class object with another object of the same class as its initializer, compared to the normal or default constructors being called when normal arguments, normal data member arguments, or no arguments are passed to it or are included in the call. A member initializer list. Class constructor this member initializer list is the structure in a constructor that matches its arguments to data members to initialize them. Classes, data members to initialize them, i.e. class test Something like that. Constructor is a function that is called when initializing an object of a non-aggregate class. Initializes the class object's data members, that initializes data members with the arguments. Declare a member function as const by putting const between the parentheses and the braces, like void print const something. Fourteen 15.1. Encapsulation is the process by which, or is the includes, well, includes encapsulation is it putting objects within a larger structure, or is enclosing, is containing multiple objects in another object, which describes classes and structs in general, but more often, and also describes the process by which describes data hiding, where make a class's implementation private, so public functions and namespaces have no access to it, and must use the public interface to access class values and behavior, letting us better control how the class is used, more safely control how the class is used, better preserving invariance, okay. 13.8, I'm guessing. Use a standard optional in a struct if the struct's data member needs to optionally hold a value to indicate whether it has value or not. Determined, something like that. I'll give some short answers. I'll give short answers like that, as concise as possible when I'm pretty versed in the thing. An alias template. Oh fuck, how do you make an alias template? Oh, I can't remember. An alias template is a template that generates aliases. Let's just generate aliases for the aliases for, is it for template functions and classes, or just template classes? I mean, I guess, yeah, it's gotta be template class because we're talking objects, we're talking using for template classes. Okay, specific alias for print t Print int, another for print double, or one for print t. A class template is a class that uses template parameters and class template argument deduction to create specific definitions of itself with data members with placeholder types replaced with matching types from constructor call arguments, which class objects are deduced matching types from these definitions. Instantiate class objects. Overload the stream insertion operator, turning a standard. Oh, hold on. Hold. By extracting user input into each member of the struct. This might look like struct test and x and y and z. Hold. Oh, duh. Well, I guess we know anyways. That's a waste. Duh. Bum. Bop, bop. Okay. Placing the nested in the public section before it's common, so it's visible in the class's interface. The order in the class doesn't matter. Yes, true. Yeah, agreed. Types in the public. Yes, exactly. Yeah, we don't, I mean, we don't need to. That's just use. Yeah, cool. All right. Can be declared inside. Non-member syntax. Hold on. A friend function is non-member, so it doesn't have at this point, but has access to private members. Yes, but I mean non-member syntax meaning that it doesn't. It's we don't call it with respect to a specific object. 2, it doesn't have a this pointer, so that we have to access the data members of a const reference specifically, because it can still see them, but it doesn't have implicit access to them. And boom, it's just called in a better way. Must be declared inside the class, but are defined outside unless it's an inline friend function. Oh, which we could do, I guess. Okay, I don't know why, but we could. I mean, we'd make it inline so that if we include the declaration everywhere, it's inline and it's not violating ODR, one definition rule. Best practice, only use friend function, a friend for non-member functions needing access. Yeah, agreed. Makes sense. Minimal use a friend. Yes, well, duh. Yeah. What's it correct? Hold. Yes, static member variables. Yes, but it's still a static member variable, yo. It's a declaration and definition. Well, yeah, because it includes its initialization. It's just default initialization in this case. As an initializer inside the class. Yes. Static. Wait, hold. You ignored MX? You ignored in text? Hello? Needs an out of class definition. Hello? Fuck. Wait, then why was it okay there? Fuck, you're right. God damn it, that is a global variable. I forgot to put in the damn scope resolution, my bad. Volatile means not optimized away by the compiler because it may change externally? What the fuck? Volatile means... Oh, so if we have something that's const expression and volatile, well, it's not going to be optimized away. So the point is... Meaning, so just something that we shouldn't be optimizing away. Interesting. I'm not sure when we would use that. Correct. Only non-static, non-friend. Have an implicit this pointer. It makes sense. Uses this. Yes, true. Okay, cool. Explicit prevent unwanted implicit conversions. Yeah, cool. Applies to single argument constructors. Sure. Well, I mean, it also explicits. It also. Well, I mean, it could also apply to multiple. No. Because the point is, if I'm creating a class and I'm passing it, it could convert to something else. So we make it explicit, so that something like that. Good bad. This copy constructors usually. Okay, that's just a signature. That's fine. I don't care. I already know that. Correct. For member initialized list, order matters. Oh yeah, because they're initialized in that order, meaning that if one depends on the other, then it's gonna be messed up. It's more efficient than assignment. Makes sense. Initialization over assignment. Yeah, because I guess we're putting something in memory, and then we're assigning it nothing, and then like we're not assigning it, but somehow that's less efficient than just assigning it from the get go. I guess probably because we have to go back to it in memory, just like a reference sometimes might be worse than value initialization because, boom, value. All we do is we copy to, or hold on. If we have a value that's stored, we just have to get the value from memory. But if we have a reference, not only do we have the reference in memory, we also have to go to the reference. So it could be less efficient if the value is small, or at least not expensive to access. Let's see, or not expensive to use rather, because values aren't expensive. It doesn't matter. Okay, constant member functions, Coca-Cola. Oh yeah, true. I didn't say exactly when. I mean, I just said you just asked when they're how you make them, but you put const there. You use them to access const member functions or const data members because otherwise you can't. Makes sense. Yes. Oh, and we can return this earlier for the hidden this pointer in order to do input chaining because we could have a function that returns this, and then we could hold. And if it returns this, it's returning the object. Well, what do we call the object? A data, a function, a member function, and then we can do more instead of doing just a member function which returns another value, and then we can't call the dot other member on it. We have to return the this first in order to keep returning the object. So we do something with the value, but then we do something else. Also about bundling and data and bundling data and methods. Yeah, don't know how that works yet. Chain optional T. An alias template lets you define a template-based type def. Wait, meaning so not specific? Hold on. The point is that we're defining the actual alias itself. For example, template type name T class test and tx template type name T using test equals test T. Boom. There's linker errors here for main because main's missing. Yep. Class templates use it to allow the creation of classes that are parameterized. I guess that's called. Can reduce the type from constructor args, but the template's still generic. Oh yeah, exactly. That's fine. And then cool. Overloading the stream operators. Hold what? Member input, prompting and extraction. Oh, well, I mean, I guess so. Well, I was just showing it, motherfucker. Oh, that was it? We already did all the 4? Oh, that was 14 and 15, that's why. Oops. Comma separated? What do you mean? Member input? I'd rather just do space. Like we do extract, enter, extract. Except instead of... Or are we saying extracting to this, to this, to this? Is that what the same... Is that the same thing? I don't want to make that from scratch. Not right now. Cool. Alright, I'll take it. Seems good. Main correction gets good use. Validations later. Yeah, it's fine. Turn the stream object. Cool. Okay. Sounds good to me. More later on member functions.